Hello everyone, welcome to our 16th video in the Python for Artificial Intelligence and Machine Learning series. My name is Dheeraj Choudhary and today we will explore error handling with try except blocks, which is essential for writing robust code that can gracefully handle unexpected situations in your code. In data science and machine learning applications, where we often deal with external data sources and complex operation, proper error handling is very crucial. So let's understand what is exceptions. So exceptions are events that occur during program execution that disrupt the normal flow of the instructions. They are different from syntax errors, which prevent your program from running at all. When an exception occurs, Python generates an error message and terminates the program unless the exception is handled. Common exception includes trying to divide by zero, accessing a list which does not have that specific index, or trying to open a file that does not exist. So in machine learning application, exceptions are common when working with external data sources, processing large data sets, or applying complex mathematical operations. Proper exception handling allows your program to detect these issues and respond appropriately instead of crashing down. So let's understand what are different types of exceptions in Python. So as we know, Python has a rich hierarchy of built-in exceptions, each representing a specific error condition. Understanding these exception types helps you write more specific error handlers. Some of the most common exception that you will see are zero division error, type error, value error, name error, index error, key error, file not found error, and import error. Let's understand all these common exceptions one by one from the total 8 of them. So I will jump to our Visual Studio Code. So over here, what is the first one? So over here, we are trying to divide 10 by 0, which is actually not allowed in mathematics. For if you do that, then Python is going to raise a zero division error like this. Then in the second example, what we are doing, we are trying to add an integer to a string. So we are trying to add 5 to apples, right, which is not allowed. So if you do that, Python is going to throw this kind of exception, which is type error. Now, so over here we are trying to convert string named 10 ten to an integer. The type is correct. So the way we are typecasting it by using integer and converting this value to integer is correct, but the value inside this is not correct. That is the reason you are going to get a value error, because you are not using the right value over here. So this is how you got the value error. Now, so as part of example 4, what you can see is we are trying to print age that we have never defined in this entire Jupyter notebook. And when you try to access some specific variable which has not been created, at that time you are going to get name error. And this is how it looks. Name age is not defined. That's what it's saying. The variable is not defined. Now, let's move to another example. So over here, now we are so over here what we are doing is we are trying to access index 5. So if I take this list and see how many indexes are present, 0 1, only 2 indexes are present, but we are trying to print a value which is situated at the index 5, which does not exist. So when you try to do that, you are going to get index error because the list because you have that specific value that you're looking for as part of index does not exist. Now, next is we are trying to access the key, that is age, in a dictionary that only has name. So over here, if you see name is Alice, there is no age. And if I try to access that, it is going to give me key error because that key does not exist in the dictionary itself. That is how you get key error. Now, when you try to open a file that does not exist, then at that time you are going to get an error, file not found error. So right now missing file.txt I don't have on my current directory. So if I go ahead and run this, it is going to give you an error saying that file not found. Now, if I am trying to import a package or a module that does not exist, at that time it is going to give you import error, that is module not found error. Okay, so these are the different kinds of exceptions which are already available in Python. So now let's talk about the try except statement in Python for handling exceptions. So this basic structure has try block containing the code that might raise an exception that we are aware of, followed by an except block that executes when an exception occurs. So if no exception occurs in the try block, the except block is skipped entirely. It is not going to run. So you can catch specific exception types by naming them after the except keyword. So over here, if you see exception type, so this exception type could be those exceptions that I showed you. It can be value error, name error, it can be module not found error. So the ones that you're already aware of, you can automatically define it based on the code that you have written, and you think that it might result in that specific error. At that time, you just say accept this, and then you can handle it gracefully. So this pattern is particularly used in data processing when you might need to handle missing values, invalid formats, or data quality issues without stopping your entire pipeline. So let's understand this by an example. So if I go over here, so this is how your try catch block looks like with the indentation. So under try, your code comes with this indentation. Right now I have written pass because if I run this, it should not give any error. That is the reason I have given. So your code comes here where I have mentioned the pass. So your try code will come here, and based on this, you can decide the exception type, and then you can handle the exception and print a appropriate message accordingly. So now what we are doing in our first example. So in the first example, we are trying to divide 10 by 0, as we saw. This always causes an error because dividing by 0 isn't allowed in mathematics. So we wrap it in a try block over here. So I say try result is equal to 10 divided by 0. And in except, I know it is going to give me 0 division error. That is the reason I have written exception type as 0 division error. And then if it is going to raise a 0 division error, it will be handled by the except block. So if I go ahead and run this, and definitely it has given the error and it was handled by the except block. So if we don't use try except block here, what will happen? The program would stop with an ugly error message that we saw above. So many a times these kinds of error message that we get, that is an inbuilt error message, is hard to interpret. So it is better that we provide appropriate information so that user can take those steps to fix the error that they are facing. Now let's see what's there in our second example. So in second example, we are trying to convert the 10 string into an integer. Since 10 is not a number, this is going to cause a value error. But instead of catching only value error, the way I did in the first example, we use except exception. Except exception means we are catching all the exceptions. Suppose if in this code there are going to be 10 exceptions which are going to come, I'm catching all 10 of them. Okay, this means so when it does, it is just going to print a message saying that something went wrong with the conversation. So this is useful when you don't know what exactly error that you're going to encounter based on the code that you have written. So for those kind of use cases, you can use this exception instead of specific exception type. Now, third example, we have simple dictionary called student with one key, that is name. Okay, and we try to print student age, that is another key that does not exist in the dictionary. So this is going to raise a key error. So by wrapping this in a try except block, we can handle the error nicely. If the key isn't found, Python jumps to the except block as we saw, and it is going to print that the key does not exist. This way the program is not going to crash, and we get a clear message and a helpful message for the user to understand that the key that it is trying to access does not exist in the dictionary itself. Now, next. Different types of exception require different handling strategies, as we saw. So Python allows you to use multiple exception blocks to catch different exception types. The order of except block matters because Python checks them in order and execute the first one that matches the raised exception type. More specific exception types should come before more general ones. So you can also catch multiple exception types in a single except block, as we saw, by providing a tuple of exception types. And we can also use as keyword that allows you to access the exception object itself, which can be useful for logging or displaying more detailed errors information. So in example, I have covered that. So let me take you to the example to show you how you can handle multiple exceptions. So let's talk about the first example. In this, the code asks the user to enter a number, okay, over here. And whenever he's giving the number, so whenever you use input, the input that you are providing, it is by default going to be string. So I am saying that enter a number. That is the reason I have typecasted it into integer, so that the number that is going to be given, it will be typecasted into, so it is going to return an integer. Okay. So so if the user types something that isn't a number, like word 10, Python is going to raise a value error, as we saw. So we have except value error block to catch that and show a clear message, please enter a valid number. And if the user enters 0, the next line tries to divide 100 by 0, which is not allowed. So that raises a 0 division error. So so over here the except zero deviation error block handles that case and prints it. So for different use case scenario, we are handling different exceptions, right? So I will go ahead and run this program. So first I am going to type 10 as a string, and when I hit enter, please enter a valid number. Okay, so it is a value error, that's why we got this. Now if I again run this, and I am, oh sorry, if I again run this and I'm going to press 0, cannot divide by 0. So there are two different operations for which we are capturing two different exceptions and we are handling them. So this is how you can handle multiple exceptions. Now let's see another example. So I was mentioning about the as keyword. So in this example, we show another way to handle multiple exceptions. Instead of writing separate except blocks as you did in the last example, we can group them in one block using parentheses. For example, maybe some code might raise a value error, a type error, or a key error. So if any of this happens, Python will jump to one except block instead of jumping to multiple that I have over here. It will just jump to one except block, and inside the block we use exception as e. Okay, so inside the block, as we use exception as e to get the actual error object that is being returned, so we can then print out the type of error and its message based on the object. So this is actually useful when you want to handle different exceptions in the same way, for example by logging them or showing a general message to the user, as we saw in the previous example where we are accepting all the errors, but over here we are accepting multiple errors based on the exception type. So in that case, you can use this kind of format also by using the as keyword. So all of them are being put to e, and then you can segregate it based on your requirement. You can also type a loop or something inside that except block and handle it gracefully. So now we are going to go ahead and talk about the else clause. So the else clause in the try except statement provides a way to execute code only when no exception occurs in the try block. This helps separate normal code flow from exception handling logic. The else block only runs if the try block completes without raising an exception and before any finally block, that we will see in our next slide. So this is particularly useful when you want to perform certain operations only if previous operations were successful. So over here you see that we have a try block, we have except block, how we were doing error handling, then comes the else. So the code, if the code raise an exception, it is been handled by exception, it does not goes to else. If the code is not raising any exception, it will go ahead and run this block, that is the else block. Let's understand this with an example. So this example is going to be a bit tricky because I am handling one value error by default and one I am raising it. Okay, so in this example, what we are doing in this example, the code is going to ask the user to enter a positive number, and inside the try block you see the first line, that is integer. It tries to convert the input to an integer. So whatever input I give, ABC, XYZ, number 10, number 20, it is going to convert that into integer, because whenever you take anything from input, it is going to be string by default. So if the user types something that isn't a number, so this int itself is going to raise a value error. Okay, I am not going ahead and raising any, but by default it is going to raise and value error. Then if the user so also if the number, now if I go to the another condition, it says if number is less than 0, if number is less than 0, again it is going to raise a value error, but with this value error I am by default giving a message saying that number must be positive. So in this small try I have given two value errors. Okay, now so if either of the error happens, the except block that you see over here runs and prints the error message. But if no exception is going to occur, the else block is going to run. So let's see. So first I am going to go ahead and run this, and instead of in the input I am going to give a string 10, which is going to give a value error from the int function. So if I run enter, it should say invalid input for sure. See, invalid input for int with base 10. Okay, now again I will run it, and this time I am going to go ahead and say -1, enter. So this time it again said invalid input and number must be positive. So over here the exception that I like value error that I raised, and I have already passed the exception over here, I just went ahead and printed that as part of this except block. Now If I am going to give a positive number, then what happens? So if we are executing a try block and it is working as expected without any exception, then it goes to else. So over here, as I have given 1, then the logic of square root got triggered, and it said that the square root of 1 is 1.0. That is how you use else block. Let's understand this by another example. So in the second example, the code tries to open and read a file called data.txt. And the file, if the file does not exist, Python is going to raise a file not found error, and except logs prints error. The file was not found, as we saw in our previous example. But if the file is found and read successfully, the except block runs. So the else block is going to run over here. So right now I'm not having the file created. So uh, let me go ahead and first run this, and it is going to say that the file was not found. Okay, the file was not found. So let me now, okay, just give me a minute. So I will go ahead and create a new file, that is data.txt. Once I create this file, oh, and now I am again going to run this code, and let's see if it goes in the else block or not. So if I go ahead and run this, see, the file contains 0 characters. So this is another example where you can understand that how you can use the else clause as per your use case. So now we are going to talk about the finally clause, which provides a way to execute code regardless of whether an exception occurred or was handled. So this block always run after the try, except, and else block. So this is the fourth one. So we already saw try, we saw except, we saw else. Now, after all these are going to run or not run, finally is going to run for sure as part of it. So the finally block is especially useful for cleanup operations like closing file, releasing resources, or closing database connection. So in data processing and machine learning workflows, the finally clause can be used to release GPU memory, close data connections, or log the completion of operations regardless of whether they have succeeded or they have failed. So let's understand this by an example. So if I go ahead and open the first example. So in this example, what we are doing is we are trying to open a file called data.txt I just created. Okay. So if the file doesn't exist, a file not found error is going to be raised, as we saw, and except block is going to print an error message. So as I said, no matter what happens, whether an error occurs or not, the finally block is going to always run. So here the finally checks if the variable exists in the local scope. If it does, we close the file using file.close. So right now we already have a file, that is data.txt. I will make data1.txt because we don't have that in our current folder. And I go ahead and run this, and you are going to get a message. See, the file was not found. That was an exception, right? So that the exception was actually raised in try. It was handled in except, but still finally went ahead and run where it said that file handling complete, where it went ahead and closed the file which was not opened. So in cut short, so finally is perfect for cleanup task that must happen whether your code is succeeded or it is going to fail. So this is going to be a default operation that needs to be performed each and every time. Now let's see in our second example, that is a more realistic with context manager. So over here we open the same file, but this time we use a with statement, WITH, which is a context manager. A context manager, and what is context manager? It automatically handles opening and closing the file for us, so we don't need to close it manually. Still, the finally block is going to run no matter what, just like before. So in this example, it is already so the operation is already handled, but still the finally block is going to run. So if I go ahead and run this, so this time I have not changed the file name because the file was already existed. So that's why you didn't got any exception or error message, but still the finally block has ran. So here's the final and the it is going to print operation complete. So this shows that uh, you can use finally for other types of cleanup too, like closing connections, releasing resources, or logging that an operation has finished, even if no manual file closing is needed. So in this case, you can use it. So in our examples, we saw that how finally can be used to close the file, to perform some other operations that are default operations. So next we are going to see raising exceptions. Okay. Sometimes you need to deliberately raise exceptions in your code to indicate error conditions. So the raise statement allows you to trigger exception when specific conditions are not met. This is particularly useful for input validation, enforcing constraint or business rules, and signaling problem in the functions that you have written. So you can raise an built-in exception type or a custom exception types that you define. Custom exception I'm going to take after this. You can also re-raise a caught exception if you want to handle it partially, but it can still propagate up to the call stack that we are going to take as an input. So in Python 3, you can use the raise from syntax to indicate that an exception is caused by another exception, which helps maintain the exception chain for debugging. In machine learning application, you might raise exception when data doesn't meet quality requirements or when model parameters are invalid. Let's understand this by example, how you are going to go ahead and raise example. So in the first example, we are defining a function called calculate square root. Inside the function, we are actually checking if the number, if the input is a number that is either an integer or a float. So it has to be an integer, number one, that is a whole number, or a float number. If it's not, we are going to raise a type error with a clear message saying that input must be a number. This is how you raise an exception by yourself. I have did that in the previous code also, where in the try block, but over here we are talking about it explicitly where you can raise your own exception by default. So that is how we do it, by using the raise keyword. So next we check if the number is negative. Next we are checking the number is negative. Once the number is negative, okay, so we are using two, right? The first one is checking it if the input is an integer or float, and next we check if the number is negative. If it is, we are going to raise a value error because you can't calculate the square root of a negative number in real numbers. So by raising exceptions like this, you can catch bad input early and prevent incorrect calculations. This makes your function safer and it is easier to debug. In real time, this is the kind of code you're going to write, and this is how you handle the exceptions. Now over here, even if I run this code, it is not going to give you any output because over here I have just defined the function with the code. But in the next one, I am going to go ahead and call the same calculate square root function, but pass 4 as input. So this causes a value error because the number is negative. So if I go ahead and run this and pass -4 as an input, okay, it has been so this condition has met, that where it should be integer, and second condition where the number should be greater than 0 but it is less than 0. That is why it has said cannot calculate square root of a negative number. So this causes a value error because the number is negative, as we saw, and inside the except block we print the error message. So sometimes you might want to handle the exception partially, for example log it or clean up, and then re-raise it to be part of other program, knowing that something went wrong. For example, if you have multiple small programs which are going to run in a synchronized manner, so if first program fails and if you want to notify what has failed in that specific program, you can also pass that exception to the other program. So in the final example, we will show you to raise a exception from an existing one. So the last example over here, what we are doing is, this is called an exception chaining, as I was talking, and it's useful when you want to add extra context to an error. Here, if some code in the try block raises a value error, the except block catches it and raises a new runtime error instead. So if I go ahead and run this, so what it has done, it has taken the value error from this and it has converted that into a new runtime error saying that processing failed as part of the exception which has been received over here. So this is known as exception chaining. This is an advanced concept. Maybe in our future videos, when I'm going to implement it in real time, you will understand it better. So now let's talk about creating custom exceptions, right? So for more specific error handling, you can create your own exception classes instead of relying on the built-in ones. And custom exceptions make your code more readable and provide more targeted error handling capabilities. To create custom exceptions, you define a class that inherits from the built-in exception class or one of its subclasses. So by convention, exception classes names should end with error. Even a simple exception class with no additional code beyond pass is useful for distinguishing application specific errors. This is particularly valuable in ML projects where you might have domain specific errors, conditions like invalid feature error, model convergence error, data leakage error, that provide more meaningful information than the generic error that we have as we saw the built-in errors. So let's understand this by going ahead and running an example. So over here in this example, we are defining two custom exception classes. The first one is invalid data format error. I said you right, the custom class that we defined, it should end with error. That's why you will see invalid data format error and model not trained error, the naming convention. So these are special error types that you create for yourself by subclassing Python's inbuilt exception class. Okay. Next, the pre-processed data function that you see over here, it is uh, a function. Sorry, the pre-processing data function that we have defined over here uses the custom exceptions that we have defined above for input validation, and it checks if the input data is a list as part of first condition. If you see, okay, if the input data is not a list, it is going to raise an exception. And it is also checking that all the element in the list are numbers. If not, it raises the same custom exception. At the end, if everything is valid, it normalizes the data. Finally, in the try except block, we test it with the bad input by passing a list of string over here. So when I use try block over here, I say pre-processed data, not a list. If I go ahead and run this, you will see data error. Data must be a list. And when custom exception is raised, the exception cache, so right now it has used this, right? The first one. It is not a list, right? We are passing a string. And if it is going to match the other one, where we are having a mix of numbers and a list, at that time it is going to raise the other one and you are going to get the error message for that accordingly. So this is how you use your custom exceptions, and then you can call that based on your function. Sorry, you can raise that exception based on the use case that you are doing. So right now I have taken a machine learning use case where we are pre-processing data, and based on that I had invalid data format error and model not trained error. But in this example, I have just called the class that is invalid data format error, not the other one. Okay, so don't get confused that why the second one didn't got triggered, because we are not using it anywhere. What's next? So last but not the least, following best practices for exception handling will make your code more robust and maintainable, as we saw in our examples. First, be specific about which exception to catch. Don't catch all the exception. Avoid bare except clauses that catches all exceptions, as they can mask unexpected errors or catch system exits that you are not aware of or that you're not expecting. Keep try blocks as small as possible, focusing only on the code that might raise the exception you're looking to handle. Provide informative error messages that help diagnose the issue if it has been triggered. In production code, using logging instead of print statement for errors to create a persistent record, we use this method. And don't use exception for normal flow control. They should represent exceptional conditions, not expected alternatives. Document the exceptions uh, in your functions that might raise by defining a doc string. And these practices are actually important in machine learning pipelines where diagnosing error can be complex and where failures might be costly in terms of time and resources, because if a machine learning pipeline fails and the model is not deployed, it results in business outages, and uh, it is going to cost you a lot. So as we have understood each and every part of it, now let's talk about the official documentation that you should go through. So over here, you can see the first one is exception, where it is going to talk about the exception, what are the different types of exceptions, as I explained you with the examples. It is also going to talk about how you can go ahead and handle the exceptions, how you can go ahead and create your own exceptions. And over here in the other link that I show over here, so this is talking about the built-in exceptions that we have. So these are the list of base classes for the built-in exceptions that we have. You can go through it one by one, and based on that you can write your code. And this is the official documentation, so these all are actually useful in some or the other way. So try to explore that. So every the different types of blocks they have created. So if you see over here, see specific exceptions, and if I go down, see exception groups, there are different exception groups. So you can explore a lot from this, from the official documentation. And thank you everyone for your time and participation. I encourage you to experiment with the concepts we discussed today. If you have any queries or thought, feel free to drop them in the comments below. I will try my level best to answer them. Remember, programming skills improve with practice. So try to apply these concepts in different contexts to solidify your understanding. Go ahead and join our WhatsApp community, subscribe to our AIML channel that you are watching this video on, and sign up for our Tech Inside Neuron newsletter. All the links are in the comments below, as well as the QR code has been displayed. You can scan them and you can join it. So see you in the next video. Take care and bye for now.